so this is a picture that was given to me by my aunt maybe 6 or 7 years ago, and it has been in my office since. So this is a picture of my great-grandparents. So I think this picture was probably taken 60 or 70 years ago, and I think I put it in my office because it just shows how much opportunities we have had compared to the opportunities that they have had at that time. So I think there's not a road there. I don't think there's electricity poles there. And you compare to us and our internets and our phones and all of the resources that we have. And even in terms of education, I think, so they probably had very limited opportunities to travel or for education. So I think this is just a sign of how Ireland has probably progressed in general and the opportunities that we have been given and we're lucky to have.
And were they on your father's side or your mother's side?
They are on my father's. They are my father's side. I hope that's correct.
Yeah, exactly. That's the same as you'll be strung up if that's not right. Yeah. So what part of the world is that?
That is in West Kerry. Okay. So that is west of Dingle. It's near Mount Breandán. Maybe you can make a connection. Yeah. So that's the second highest mountain in Ireland. Is in the background there, but it doesn't show up in this photograph. Sure, yeah. So it's right at the Atlantic Ocean. The cliffs are behind you there.
And were these people, were they farming or?
So they would have been farmers. So very small farms. Everybody would have a field here and then another field down the road and somewhere else. So they would have been farmers, cattle and sheep, most likely. But they also would have been fishermen.
Okay.
So there's Breandán Creek, which is just around the corner from here as well. That's where St. Brendan set off to discover America from.
Very good, very appropriate.
In his little canoe. So they would go out from there in the little nave-ogues and they would go out fishing, catch salmon, pollock. And then put them in salt barrels for the winter and keep them there, and that would be their food or their fridge for their.
It really does sound like you're describing something from another era, particularly in Ireland. Like, if you went back to this exact spot now, it would look entirely different, I'm sure.
Not entirely different, actually. That same road is there. That house is being renovated by their great-grandson, I suppose, as well. But there is electricity poles, there is sewerage, there is Wi-Fi, there's broadband. Yeah, so it's quite a busy road. It's part of the Wild Atlantic Way now.
Okay.
So it's busy. But yeah, this is not 1,000 years ago.
Yeah.
This is 50, 60 years ago, maybe. That's all it is.
Amazing, yeah. Ireland really has changed.
Yeah.
Really has. So what are these other pieces of paper then on the table here?
So maybe I'll start with this one. This is one again that has been in my office for, I don't know, since when was this? Since for the last 6 years. And yeah, this is the contrast. I never thought I would have been invited to Downing Street by the Prime Minister's wife. So this is an invite to 10 Downing Street. And unfortunately, I never got to go to the event. But I always thought it was an amazing thing to be invited to go to 10 Downing Street. And this was part of a work that I work with a charity called Retina UK, they're called now, and they had an event at 10 Downing Street.
And the other ticket there, what's this? That is?
The other ticket is the midsummer soiree or the ball, the Farm Talks ball. So we set up the Farm Talks Society maybe 10 years ago with some of the PhD students. There was kind of a lack of identity of where everybody was and where they belonged because we'd moved into a new building. And so we re-established this, and we had a conversation one day saying, we should have a ball. And nobody thought we could actually have the ball. And the two students, Hayley and Temmie, they went and they organised the ball. And we've had a ball every year since, and we raise funds for Mental Health Ireland, PA the House, colorectal cancer research, breakthrough cancer research this year. And this was the ball that got cancelled because of COVID, so the ticket was never used.
Brilliant. So 2 tickets that didn't get used.
Yeah.
Right, kept for some reason. Isn't it funny? If you'd gone, you wouldn't have kept the ticket.
No, they wouldn't have kept the ticket. Actually, and this year it was electronic tickets. It was you swipe
no ticket
on
anymore
your phone.
At all.
Yeah.
Oh, here the world has gone to hell in the handbasket. So what's your name?
My name is Breandán Kennedy. I'm a Professor of Pharmacology in the Conway Institute in UCD. and my research is related to vision, how vision occurs, blindness, genes that are associated with blindness, looking for drugs that can prevent blindness or restore vision, and also looking at cancer of the eye.
Okay, so how on earth do these things get? What are these? Why would somebody like you, studying such a exotic sounding thing, and a thing that obviously requires a lot of equipment and technology, what are these?
So these are very simple patterns of black and white stripes, but I would also say they are very effective in what we use them for. So we are interested in looking at vision. We're interested in drugs that can restore vision or gene approaches that can restore vision. So you can look at different aspects of vision, but the most important one to us is actually vision itself. So we use a zebrafish model, which are small tropical fish, and we're able to use these to look at forms of blindness in these fish, but also drugs that are able to restore vision in the fish. So the key question there is, how do you look at vision in a fish? How do you measure vision in a fish? So we can't give them eye charts. We can't ask them to feed back and tell us what color they see. So instead we use what are called behavioral assays, and the fish will be put in a drum at the bottom of this, and then this will be put on a motor, and this drum will be rotated. So the black and white stripes will move around, and a fish that has good vision will track the movement of the stripes with its eyes. And that's called the optokinetic response. So it's something that we also, the optometrists, use in humans as well, is the ability to track the stripes. And this is the easiest one to see. It's the biggest stripes, the biggest contrast. And then as we get to smaller stripes, it's more difficult to see them. And we can also make it grey and white, so it's even more difficult to see the contrast. Or we also have stripes that have black and green, or black and red, or black and blue. So,
and are you actually able to measure the fish's movement, like the sort of nuance of how well it is tracking this more difficult one to the way it's tracking the easier one? Are you actually able to kind of measure that or track that in some way?
Yeah, so we have a simple quantitative way, which is we rotate the drum 30 seconds one direction, and we count the number of times they move their eyes in 30 seconds. And then we rotate the drum 30 seconds the opposite way, and we count the number of times they have a full response, and that's the number of saccades that they have per minute. Okay. And as the stripes get more difficult, they will have less saccades, but also if we have a model of blindness, they may not respond to the lower stripes or the lower contrast. And again, then we take this as a reverse, where we look then to find a drug or a gene intervention which is able to take a model of blindness and restore its vision. And we can see that because it's significantly increased the number of saccades, or it's able to see the middle pattern of stripes where it couldn't before. It's still not maybe able to see the lowest. So it's a bit like it's to improve or preserve the vision that they might have had.
And you've actually been able to do that, to restore vision?
Yeah, so the pun here is that doing something like this is a fishing trip, right? So this is what reviewers would often say: how can you find a drug out of the millions of drugs that are out there that are able to restore vision? And until we had one, we could never say we could do it. But we have found the first one of those maybe 8 years ago, probably at this point. And we've continued to work and find other drugs, or to take those drugs and work with computational chemists, where they'll design it, they'll modify the structure, or they'll search a database of all of the drugs and say, this one is similar to your one, and we'll take that drug and then we'll go back again. So yeah, at this stage we have several classes of drugs that are able to restore vision in that model that we have.
It's incredible, it's absolutely incredible. So all of these sort of very ordinary looking objects are objects that you use in your lab. What do you do with that?
So these devices are, or these tools, They're all part of the fish facility. So we maintain the zebrafish in stocks, and so there's lots of them kept in individual tanks, and you have to have a water supply that comes into the tanks. You have to have the water come out. It has to be cleaned up. It has to be filtered, and then has to be sent back around again. So it's like a recirculating water system. And with water systems, things can break, and so